som I er, det er jo trods alt. Yes, the French guy, or the guy with the French accent, has some question already?
Det er du engelske sprog.
Pardon?
Det er du engelske sprog, fordi du er ansat.
Oh yes, I will do it in English. Good point. All my slides are in English as well. So that's all right. So to begin from the beginning, it's very nice to see so many young people here. So I believe most of you are students, right? Most of you? Yeah, that's good. So I'm here, and I will not talk that much about BIM in the design and construction phase. This is very much how to leverage the BIM information in the next step, the lifecycle management, the maintenance and operational use. And that is very much also of high interest to combine that with the GIS technology and facility management. How many of you are aware of GIS, Geographic Information Systems? Okay, pretty good. And facility management? All right. That's nothing brand new. All right, good. So, I'm from a company called InformiGIS, and we are a private-owned Danish company. 90 people, 3 offices in Denmark, and we are very much, as the name also says, focused to GIS. But the thing is, what's happening is that BIM as a source, data source, becomes more and more important for many different purposes. And that's a little bit what I will try to explain how that can happen in combination with GIS today. So we base our solutions on 2 main IT platforms. From Esri and from Archibus. Esri is the GIS, the geographic IT platform, and Archibus is the facility management platform. So we've been a partner with Esri since 1993, Archibus since 2006. Right now we are implementing Archibus at the Bispebjerg Hospital. So this is our first implementation in the healthcare industry. And this is one of the industries we see most beneficial opportunities in the near future. Very interesting. And of course, in that sense, from the healthcare, GIS technologies are also very well used. I've been there for quite some time, but now the combination of these tools, especially the analytic tools we have for very can be used as well. So this is something I will explain a bit more. So Esri, yes, and when you think about GIS, you think about 2D maps. That's correct. But lately, 3D GIS is also of high interest. Especially some years ago, Esri bought a Swiss company called Procedural. And Procedural was very good at so-called procedural modeling or parametric modeling, but where you can build up this very fast. So mainly the gaming industry have been using this technology. So for instance, if you see Cars 2, the Pixar movie, that's been done by procedural technology, which is now called City Engine. So that's quite interesting. So, and the thing is here, which is interesting, is that these procedural models can be created from GIS data properties from the database, geodatabase. Directly plug it in and use those properties as parameters to design your city, and it goes very fast. And of course, then you're having new buildings it could be for BIM, which we can import directly, and then we can maybe have various BIM models to compare directly. So this is very much in the early stage, where the politicians and designers are looking into this. But what I've discovered lately is also that there are other interests, other segments of industry segments which are very interested. First of all, hospitals, mainly for maintenance and operational use during the life cycle management, but also firefighters, police, intelligence are quite interested in what's inside those buildings, because in fact, when there's a operational task to be done, they don't, in principle, don't know anything about the building when they enter the door. So that's something which is of high interest for them as well. Okay, so some of you have heard about GIS, but for those who don't, so GIS has been a technology been in existing last 20 years. And Israel is one of the biggest ones today. They are the world leader. And they have been going very heavy development on some issues I'm going to explain later about big data, cloud computing, and all this stuff. But mainly, the core functionalities of GIS is to be able to combine various data sources and group them together, and to be able to visualize it, question, curate it, and analyze it, and interpret it, and see what's the relationship, patterns, and trends, and then map it, show it as maps. So, and also what's really quite interesting is that, as I mentioned before, GIS has been mainly known for the large scale, the regional, the urban design, geography, but now building geography is becoming part of the data source. So we can go in from the world scale level to the building interior, like this room. And where we then are using some of the BIM assets to combine that with other data sources. So we're using, in principle, this room as a data portal to gather other information, which could be CPR, BBR, or other data registers, which then we can promote via the space, the BIM space. So that's quite interesting. So this is the traditional scalability using GIS. So you have a very clear line between GIS and the CAD BIM space. So when we enter the building, this is very much between CAD and BIM space, and still is, of course. GIS will not replace that, I will just say that. And GIS is not a tool, a BIM tool for modeling, not at all. It's a fantastic tool to aggregate information from various data sources, also BIMs, to use that as an information source combined with other data sources. That's the key thing. But what's happening, of what I will explain, is, as also mentioned, that suddenly we can now aggregate information like room and assets. Many assets are quite interesting, especially if we're talking healthcare. I mean, I don't know if you know how many millions of kroner just go down the drain here in Denmark or in other places because they don't know whether the beds or wheelchairs or medicine disappears or medical equipment. We talk about hundreds of millions of kroner every year, and this is our tax money just down the drain because they don't know where they are. They just vanish. So this is a big thing, and in that combination with the building interiors, it's very interesting also that we can build up some transportation network inside the buildings. So the buildings are interesting in many aspects. And what's interesting for us as a GIS folks, I haven't really introduced myself, but maybe I should do this now. So I do have a GIS background. I have a Master's of Science in Geoinformatics from Aalborg in KGS in Stockholm. And for me, I have been in Informa for a year. But previously, I worked 5 years in building systems, which is very much like Autodesk, it's a competitor to Autodesk. And then I realized during those 5 years that the technology in the building industry is, of course, very comprehensive, but it's definitely also very interesting to use some of that technology in the GIS world and to combine that, because that gives some very interesting aspects. So when we see BIM models, very often it's one building, and it's in their own coordinate systems. Well, when we're talking about buildings, we're talking about buildings in a geospatial context, meaning that we know that this building is exactly on this spot on the map. We know the coordinates, we know exactly where they are. And that means we can combine it with other information layers like street network, utility network, transportation, for routing purposes. So not only we can route outside, we can continue our routing indoor as well, because we have placed in the right location. And then it's a bit tricky when we have to aggregate information, because typically the data is not georeferenced. And some of the software, especially Revit, really sucks when it comes to handle geographical coordinates. Maybe it changed. That was some years ago. Maybe it changed. Please correct me if I'm wrong. But most of the BIM tools are really bad to handle this part. But it's improved. So I know Bentley and also Graphisoft is pretty good at it. So, and as I mentioned, when we can leverage that information into a database, combine it, stack it up with all kinds of other informations, we can suddenly use it as a code for a platform carrier. But we can many other informations, and we can enter the information visually by going inside the building and request what kind of information you want to extract and what kind of information you want to edit. So instead of having various systems, I can extract from various databases and systems and put it up one place, edit it, put it back in. Okay, but there are of course some fundamental differences between BIM and GIS, and there will always be, and there still will be in the future. But GIS is, we work very much with databases. We love to structure our data. In fact, we only work mostly with structured data. And when I talk about structured data, I mean, then we know typically the location, we know the lot of properties, and then it's related in via a common data model. So we have some kind of schema. And this schema is unique for all kind of users. So they can use the same schema. So so they have the same picture of what they're seeing. It doesn't matter if they're local government, state government, or emergency management. And we have very huge number of users in many various aspects. So local government, state government, law enforcement, firefighters, etc. Many are using GIS technology today. And we also have, and lately we are very much work on cloud-based infrastructures. So we're pushing very much of this information in the cloud environment and work very much with the mobile devices. So this is the big trend in the GIS world. And here in the BIM, you know this much better than I do, but we work very much with file-based, and I definitely see this as a showstopper sometimes. So we have to, since I'm from here, from this world, I want to put this in the database. I want to structure this information via a data model, meaning that I can then query and aggregate information and visualize it for only that purpose, that specific purpose, and then like maybe I have 10 different purposes, 10 different people who are having 10 different requests, but they're using the same source, one source, to retrieve the information from. But they can get 10 different or 100 different requests and visualize differently, depending who they are as a person, what they want to see. But any change that happens in the database once, everyone will see the changes immediately. Yeah, so you know this. And of course, when we're talking to aggregate some of this information, this of course, BIM is very complex, and there's tons of information, and in principle, very few of these informations are really of interest in our world. But of course, if you're talking to a firefighter, what's interesting very much is the spaces, doors, windows, what kind of material is the wall made of, what is the fire class. If you're talking to let's say, the intelligence service, they might have some other requests. They want to know, okay, what kind of noise level do I make when I stand here in this room? I want to drill a small hole in the wall, stuff like that. Or you're having the facility manager who wants to maintain the building. But there are information in these models which are of high interest. So this is some examples where we aggregate some information. So this is very much used in the urban planning in the early stages, where we're only extracting retrieving the spaces and make some 3D thematic maps. So this could be automated, completely automated by using CDN2, which is this procedure modeling tool, where we just hook to a database and then we could visualize that. We can then we can share it with everyone. And here we have some more details, more canvas visualization. I'm going to show you this later on live, hopefully. And this is also very interesting, the transportation network, especially if you want to say, okay, if I'm at that room and want to get up there, what is the fastest way? If I'm interrupted here, what is the alternative route? That is something which is quite interesting, especially in the healthcare industry, because if you want to optimize transportation in the hospitals, not only for staff, but very much for very assets. It could be medicine, it could be blood, it could be that the doctors are moving very much that route, but why not if you change that operation room, if you move that, they might save some time for the transportation. So, and also for emergency management, it's also quite interesting for this part. And of course, if you then start using smartphones and you come in as a visitor, I want to say, okay, I want to visit my grandma and she's room 202 on the 10th floor, then we can use this network to guide you to the room. So that's one of the intentions as well. Okay. I've already said all this properly, but this is very common when in the GIS world. We are always having data models, which in principle is a schema, and we always have databases. It doesn't have to be one database; it could be many various databases. And also, something is that GIS has really a benefit. It's scalability. We can go from, as I said, from a room, and we can take an entire building, an entire region or city or even country. So we work at different levels. And then the GIS have some very powerful tools, the analytic tools, where you can do various of analysis and visualize afterwards. I have some examples from what we can do. So this is, as mentioned earlier, that for wind speed or is when you're building and see how what's the wind influence in the area. Well, that's one building, but we can take the entire city in if you want to, with the terrain models, the trees, with all kind of infrastructure and run through a simulation. And as well with the shadow visibility and right to light studies as well, we can do it because everything is georeferenced, meaning we know if we are here in US or in Saudi, and then we can make those maps. This is very common here in Denmark. Flooding, especially insurance companies are quite interested to see what kind of buildings, houses or residences are going to be flooded. So we are, and especially now we're having this free data from the mapping, from the geodata student. So we now have the terrain model and technical maps free from, which is free of charge, so you can download it and use it. So this is something we are very interested to put out as a service, so we can directly aggregate the terrain and map information and build up some simple 3D models as well. This is very interesting when you're talking about emergency management. So here we can directly interact with weather information, live weather information. So wind speed, wind direction, and then if this is a chemical pollution, what will the influence be? And then using the GIS technology to see, okay, what kind of buildings is influenced or in this area? Who's listed? How many people listed? Okay, we know, and then when you make the report in a very short time, then you have to say, okay, we have to evacuate so many people. We have a critical infrastructure in this area, which we have to plan our planning for. So this is something we can do live. This is very interesting. So going back to Esri, looking at some of the trends. I mentioned all the cloud world. This is I've been investing enormous amounts in the cloud for years, and also big data. A lot of talk about big data, but it's the reality, especially with what we see now coming up with a lot of sensor technology. So especially in the healthcare industry, have really an issue with big data because they are using sensors in the various way much more. And we can now we're now using some open source big data systems so that we can handle billions of feeds and process it on less than a minute. So meaning this is something really looking to. Also augmented reality. It's quite interesting. This is primary and defense industry. And then we have the mobility. Everyone wants to have information on tablets and smartphones. And not only in 2D, but also 3D. Be able to stream it. And gaming industry is also quite new, but especially with the procedural technology, this is also quite interesting. And then we have a new term called geodesign. So it's not about designing a building, it's more designing a building in context with the interior, with the exteriors, terrain models, road network, and etc. to visualize that in that context. And then we're having GIS and CAD, ESPN part of that as well. So this is very much the trend in GIS world. So you see the closing in, that's very interesting. So yes, we have what we call the ArcGIS. This is the main platform, and we're having the traditional desktop. We have that for many years, and we still have that for many years because all the very powerful computation is still going on the desktop. But the server is taking over more and more because we have the big server parks, meaning that much of the processing will happen on servers, which are very much used in the cloud-based environment because the thin clients do not have the processor power to process the data, so that will happen in Sphere. So those applications or apps are made. We have some GeoVim processing tools that can feed those functionalities in the cloud. And this is talking about cloud. This is a big thing. So the scope about this is that you have one map on any device. So we're supporting all the platforms. And it's very much also about supporting building information as a layer, the building assets. And also a big thing is the social media. That's very much used for marketing purposes, but also for various other purposes, like police, and also in Denmark, Copenhagen police are using social media for crime analysis. And it will happen more and more. There are a lot of research going on this, how to aggregate information from the social media for that kind of functionality. And this we have ArcGIS, what we call 3D cities. So what Esri have done is they have defined a data model called 3D urban information model, meaning that we can take care of all information on top of the ground and below the ground. And then we have various various functionalities. So we can navigate around the city. We can do some zoning, see if there are any violation with the zoning regulations. So we can visualize that. We can make some classing technologies to highlight if there are some issues with some new designs. So we can directly embed the zoning regulations. That can be done in 3D as well. This is very much used in Switzerland, for instance. They're very much using this technology. But also that you can track information, so you can query and find information and use this variety of functionalities. So little more about this information model. So you see there are many layers of information, and so it could be for the natural environment, the legal environment, and the built environment. So building and building interiors is part of that. But you have many other kind of information which you can add in. But the main thing is that it all have some relationships between each other. That's the benefit of GIS. You have the relationship on the multi-scale. So what if you look into what we can support, kind of information we support, I see we can see the GML is something we've supported a while. We can take directly into the data model, which is a schema where we're organizing or unstructuring our data and then into the database. BIM directly is nothing that is really supporting that you can read in a Revit model, for example. We don't have a connector to Revit. But what we are interested in is to have something called the the BIM server technology. Anybody aware of the BIM server technology? I would like to discuss with you about that, because that's a very interesting thing to put in here, because one thing is to extract aggregate information, but still what's interesting here is still have the connection with the original data source. So if any change happens, you can trigger a database update. And also, the main thing here is the sharing of information. So when we have generated the content, the 3D content, we can then, using this city engine technology, to promote it on our cloud-based data structure, and then we can share it. So we have some models on the Esri's webpage, which you can download and open in a browser, standard browser. So you don't need any plugin. You're using the web shell technology. So for instance, Chrome, Firefox, and Safari, and also Explorer is supported with the Chrome plugin. But those three browsers are natively supporting the 3D WebGL. So you can directly load it in, and you can share it with anyone, or with just a group of people. You can define that by yourself. So maybe I should, let's see, here we go. So here are some examples on the homepage which you can, everyone can try out free of charge. So this is an airport. Here we have a campus area with the building interiors. Here's some of the 3D zoning. Here are some visibility studies. Yeah. But let's try to open one of this. So, okay. So here is a, this is directly taken from the cloud. This is not something on my computer. This is a cloud service as we have somewhere in the US. So here is the model. And you can see there are some more details and some less details. If I look into this, I can click on building, and I see my properties over there. So maybe not that interesting, but some properties are there. This is auto-generated from the GIS database when you're using the building. If you're having a PBR, you know PBR? Bygningsområderegister. You have a lot of information there. You have the number of floors, type of usage, building year, technical installations. I mean, this is perfect for parametric modeling, for precision modeling. You can also generate, you have to make some rule sets, but when you're done rule sets, you can auto-generate, in principle, entire Denmark. Because the BBR are connected with the building footprint from the port map, which is provided from the GIS Geodata Suite. So a nationwide 3D map, and that is something Esri will promote here in May. Let's go, let's see, I have something here. let's go in and dive into the campus. So this is a campus model. And you see here, I have some layers as well. I can turn them on or off directly. And I can also say, okay, I want to take off the walls. I have some slide here, if you can see them there. So you can directly do that. That's standard. But I can also, you see here's bathroom, so we also support 3D symbologies, meaning that we can replace geometries, complex geometries can be replaced by symbologies. And it has also the properties. So for instance, you can see this is a women's restroom, and you can see the floor area, and all kind of other information. You can put in height and elevation, all the stuff that you put in directly. Also, what's quite interesting is the search functionality. So I can search directly. And now this model is integrated with the employment systems. So in this building, I know I have so many employments, but also who and where they're located. So if I search for Kelly, I've got 3 Kellys in that building, or 4. So if I click on this Kelly, I zoom in directly to Kelly. So here she is. Here you have all the properties about Kelly, or some of it. So that's just a little bit about the integration. We can also integrate with the ERP systems or other systems, and all our FM system from Archibus. So using this as a front-end visualizer, and then we can extract information from the FM systems as well, and use that to feed the model. Okay. And then as well, you can share it here again. You can share it on Facebook, Twitter, email, or whatever. There are many opportunities. So if you want to do that with some friends, you can do it for it. And this will also run July. This was also run on smartphones and tablets, US, Android, and only so. It's in beta test right now. What's not been shown here is, this is another model, this is from Philadelphia. But here you see the traditional city. This is based on oblique imagery. So that's, but what you can add in here is that we have done some processing of some analysis. So I can see, okay, I want to see right-to-right studies. So here I will change the underlying map, and then suddenly you can see a thematic map showing you where to have most light on this map. I can well add that, and then I have something. You can see this is a nice build. This building here is new. This one here. So I can see, okay, this is the proposal, and this is the as-built as it's built today. So you can change it, and you can maybe have 5 or 6 different opportunities here. But this is a new building, and you can see also the shadows change and all of this. But you can also make some visibility studies. So this is a visibility study showing you what influence that building has on all the other buildings. So the more red, the higher influence you have. This is something we have done on the server side, and then we push it as a layer together with those other informations out on the web, on the cloud. And it's free available. That's a perfect opportunity to interact, and you can decide whatever, what kind of information what you want to put in here. So when you make when you generate the model, you have to figure out what kind of information you want to have in the cloud. free available. So that was a little bit about cloud-based. So, I mentioned this already. So it was this is going to be very interesting. What you saw here was pretty. The 3D scene to be created today is not that big. It's quite small as you saw here. We will support we are working on another format so we can compress it differently. I mean that we can have larger data sets. And we can also push it out to the mobile devices. So that's, and also we can stream it. There will also be some streaming technologies on the workloads as well. And I will, this presentation for the history part with this one, because I mentioned healthcare quite many times, and healthcare had a huge issue for asset management, and so to maintain the assets, real-time location systems is something that's going to be implemented in many projects, and for tracing and tracking. And the thing is that we're doing it use basic concepts. So it's not only for that building with that system, we can also do outside the building. Meaning, let's say you have a wheelchair. That wheelchair is inside. You want to know where is my wheelchair. And you have the indoor map, you can see, okay, it's over here. But you can also say, okay, when that wheelchair leaves the building, you can still track it outside because we're working in real coordinate systems, worldwide coordinate systems. And we can even use some other technologies called geofencing, put up some alarm, say if that wheelchair is leaving the hospital area, alarms will pop out saying that wheelchair is leaving with that car or whatever. But it's to the speed of 90 kilometers per hour and where it's heading. And I tell you, hospitals today buy wheelchairs on a regular basis because they disappear. I mean, I'm pretty sure there's some organized crime behind this. But with this technology, we can start finding out who the guys are. So, okay, that was the S3 part. That's what the S part. Now I move over to facility management. And so InformiGIS is a huge provider of facilities and real estate management software. I've been there for more than 30 years. And as I mentioned, this hospital is implementing this right now. And the main thing for them right now is space and movement. Many hospitals, in fact, do not exactly know how many square meters they have, how many rooms are occupied, not occupied. I think this year found out that about 15% of their spaces will not be used. And another thing is that they want to relate each person with some assets. Meaning, because they're building a new hospital site, several buildings, they have about 10,000 moves they have to manage. And there's a cost related with each move. So each person has some assets related, so like a chair, a table, installations, technical installations. So every time you move a person, you can estimate a cost for that move. And you can also say, okay, I want to move that department or that group of people, where does it fit in best in that building? So you can make some matching technology as well. So this is the main thing, but also for portfolio management as well. And also, later on, hopefully, we will introduce the GIS technology, because what's also very interesting in the health industry is when you are patients, about 3,000 persons each year got an infection because they are in the hospital. Meaning, if there could be some kind of epidemic, so you can hospital suite for it. The thing is, they don't know which person, which equipment have been in that area. But if you're starting tracking that equipment, you can roll back the time and see, okay, that equipment, that personnel have been in that area, and then you can visualize where have they been for the last 24, 48 hours, and said, okay, these areas have to be in quarantine. Stuff like that. That is very interesting. Okay, so about IGOS. The thing with IGOS is that this is a server-based technology. So it's no desktop, it's only a web, it's a web server and web-based. So it's in clients. What IGOS have done is they've been working very close with ArcGIS. They're both based in Boston. And so they have plugins directly for Revit and ArcGIS. So meaning that we can synchronize CAD and BIM data directly with ArcGIS' database. And that's something that it will do in BCBF. They are, all new buildings are will be in the BIM, and they are aggregating that information to the, or synchronizing that with the FM database. Then, what they're doing as well, or will do, is also integrated with the SAP, that ERP system, for the work order management. And you probably know this, so I think I will skip that out, but that's the whole idea with the facility management. That you are not, the main issue of being, when you talk about facility management, that you're very much looking at the cost of the design construction, but not for the whole life cycle. So BCBF have changed mindset, said, no, we're looking at the total cost for the entire life cycle of that building. So that's quite interesting to see what that influenced. And that's why they're doing the investments now, even before the construction. Yeah, so we can support it directly. I mean, and the way it's done is that we have some bi-directional synchronization features. So you're mapping the features or the assets in the BIM model with the database, and then you establish the synchronization. So if any change that happens in the BIM model, it will automatically update the FM database. There's some examples for that one. So it's directly, so if you open up the Revit, you have directly that add-on in the tool as well. And then we also have the opportunity to integrate or to embed the S3GIS technology. So this is a dashboard where we embedded a GIS map. This is just a map. In principle, all kinds of assets can be visualized on this one as well. So here we are running on the FM database and on the Geo database, and they are also connected. And here another example that we can combine as well with the 3D models. So this is the front end, as I showed it before, the city internet viewer, and we can then make thematic maps based on the input from, based on the properties from the ArcGIS database. To use that as parameters to make various thematic maps. Yeah? So, what do you think?
Make a workshop that teachers how to do it.
I would love to.
Yeah.
Which part? The S3 or the ArcGIS? Both?
Was this in Denmark? We are in Denmark, and if you have access to all the data you said, freely,
Yeah.
and ask them to map the...
Yeah. We are, right now we are working on the Aalborg region in northern Jutland where we are modeling the hospital. We don't have catwalks, unfortunately. And then we are combine that with the 3 days of the 3 geo data, as I mentioned. And then we will combine this with live sensor feeds as well. So we will be having a 3D model based from 3 geodata, a more complex model of the hospital, and then in that rooms we will have static and dynamic sensors, which will give us a lot of feeds, and we will then visualize those feeds on the 3D map as I just showed you before. So the idea is that we will see, and then we have some pseudology showing wheelchairs or beds or whatever. You can embed that in a line map. And hopefully we will be have finished that after summer or in autumn. And then the idea is that we will show that. And I'll tell you, it's not only here in Denmark, it's a huge interest. Also in the US, there's a huge interest for this. Because they don't have the structured data as we have. So yes.
How detailed is your terrain model?
It's based on a laser scan, and this is something which were up in the tender for tidligere former KMS, now TST. So they have a grid size of 1.6 meters. So that's, and for some purposes it's okay, but if you want to use the lighter point clouds to auto-generate building geometries, it can be quite difficult. We have tried to auto-generate the roof geometries from the point clouds, but you have to have more dense points to do that probably. So, yeah. All right, thank you very much.
So we'll be back here at 1:50. So, thank you.
Stab.